Warahmatullahi wabarakatuh. So my name is Mas Samdi bin Kamuji. Okay. Mas Samdi bin Kamuji. So I will teach all of you about linear algebra. Okay, so first your mark. So your mark divided into two. So first is continuous assessment, which is 60%, and final assessment 40%. Okay, so final assessment is final examination. Okay, so continuous assessment, it is consists of test 1. Okay, so test 1 15%, and test 2 15%. Okay, so this one for your assignment. Okay, so your assignment I will inform later, because in this situation I don't know we can do the presentation and case study or not. Okay. Okay, so for this first week, okay, so we will learn about matrices. Okay, so about matrices. Okay, so matrix, what is matrix? So matrix is rectangular array of numbers in rows and columns. Okay. So for example, matrix A, B, and C. So this one is rectangular array. Okay, so the shape of the matrix is rectangle. Okay. So the matrix can be denoted by capital letter A, B, C, and so on. And numbers in a matrix are called entries. Okay, so this one. Okay, so this one we call it as entries. Oops. Okay, so this one we call it as entries. A. Okay. Entries. So for example, matrix A, we have 4 entries. Sometimes we call it as element. 1, 2, 3, 4. So matrix B, we have 1, 2, 3, 4, 5, 6 element. And matrix C, we have 1, 2, 3. Okay, so numbers in a matrix are called entries, and it can be denoted by small letter A, B, C. Okay, so size of matrix is determined by number of rows and columns. Okay, so we look on matrix A. So we have here 2 rows, 1, 2. Okay, so row 1 and row 2, and the column we have 1, 2, column 1 and column 2. So therefore the size of this matrix A is 2 by 2. Okay, so matrix B, so we have 1, 2, 2 rows, so row 1 and row 2, and the column we have 3, 1, 2, 3. So column 1, column 2, and column 3. So therefore the size of matrix B is 2 by 3. Okay, so matrix C. So matrix C, we have 1, 2, 3 row. So 3 rows. So row 1, row 2, and row 3. Column we have 1. So 1 column, column 1. Okay. So therefore the size of matrix C is 3 by 1. Okay, so next. Okay, so this one is general form of matrix A with size m by n. So another examples of matrices. So this one. Okay, so for this one is 3 by 2. Okay, so the size is 3 by 2. Matrix B is 2 by 4. Matrix C is 1 by 3. Okay. So next, transpose of matrix. Okay, so if A is m times n matrix, then the transpose of matrix A is, we write as AT is an n times m matrix. So transpose of matrix A is obtained by interchanging the rows and columns. So rows become column and column become rows. So for example, matrix A. So the transpose of matrix A is AT. So equal to, so this one column. Okay, so the column will become row. So A, B, and no B, A, C, and then B, D. Okay. So B, D. Okay, so matrix B transpose equal to, so this one column. Okay, so column become row. Okay, so 1, 2, 8, 5, 2. Okay, so now the shape of the matrix already changed. So before this, matrix B is 2 by 3. So now B transpose is 3 by 2. Okay, so previously matrix A is 2 by 2. So matrix A transpose is 2 by 2. Okay. So how about matrix C? Okay, so matrix C, this one is column. Okay, so C transpose is equal to, okay, so column become row. 5, 2. Okay, so 5, 2, and 0. Okay, so previously is 3 by 1, and for the C transpose is 1 by 3. Okay. So next type of matrices. So we have column matrix or column vector, row matrix or row vector, square matrix, diagonal matrix, identity matrix, upper triangular matrix, lower triangular matrix, and symmetric matrix. So what is column matrix? So column matrix is matrix with only one column. Okay, so dia ada satu column sahaja. Okay, one column. Example, so this one. Okay, so one column. Okay, this one is column matrix. Row matrix. Okay, so row matrix is matrix with only one row. So for example, this one, so one row, this one also one row. Okay, so next, square matrix. So what is matrix? So square matrix is a matrix with same number of rows and columns. So example, so this one. Okay, so we have two row. Okay, so we have two rows. Okay, so two row, 1, 2, and 2 column. Okay, so W, matrix W, we have 4 rows, 1, 2, 3, 4, and 4 columns. 1, 2, 3, and 4. Okay, so the number of rows and columns are same. Next, diagonal matrix. Okay, so diagonal matrix. What is diagonal matrix? So diagonal matrix and the square matrix with all the elements are 0 except the diagonal. Okay, so the diagonal not 0. Okay, for example, matrix D, we have the diagonal 1 and 2. Matrix W, we have the diagonal 1, 7, 1, 1. Okay. Next, identity matrix. So what is identity matrix? So identity matrix is diagonal matrix with every elements on its diagonal are 1. Okay, so you can see the example, matrix D and matrix W. Okay, so all the diagonal are 1. Okay. So next, upper triangular matrix. So what is upper triangular matrix? Okay, so upper triangular matrix is square matrix with every entry below its diagonal is 0. Example, matrix D and matrix W. Below this is diagonal. Okay, so below diagonal are 0. So this one, matrix W is diagonal. Okay, so the below one are 0. So the below diagonals are 0. Okay, so next, upper and lower triangular matrix. Okay, so lower triangular matrix also square matrix with every entry above the diagonal is 0. Okay, so example, this one, matrix D. Okay, and matrix W. Okay, so you can see here above the diagonal 0. This one also 0. Okay, so last one is symmetric matrix. So what is symmetric matrix? Symmetric matrix is square matrix where the transpose of the matrix equal to the matrix itself. So matrix A equal to A transpose. Okay. So matrix A equal to A transpose. So for example, D equal to 2, 3, 3, 1. So D transpose is equal to so column become row. So 2, 3, 3, 1. Okay. so column become row. Okay, so still same with the original matrix D. Okay, so matrix W, another example. Okay, so W transpose is equal to same, column become row. Okay, so 1 3 6 3 2 1 and 6 1 3. Okay, so same as the original. So this one is symmetric matrix. Next, basic operation on matrix. So first we go to addition and subtraction. Okay, so this operation can be done if two or more matrices has the same size. So for example, okay, so this one, for the first one, okay, so 2 by 2 matrix plus by 2 by 2 matrix. Okay, so the answer is 1 plus 2 and 3 plus 6. Okay, 4 plus negative 1 and negative 1 plus 5. Okay, so you have 3, 9, 4 minus 1, 3, and negative 1 plus 5 is 4. Okay. Second one, also same, 2 by 2 matrix minus by 2 by 2 matrix and plus by 2 by 2 matrix. Okay, so the answer is 2 minus 1 and then plus 2 and then 4 minus 1, 4 plus minus 1 plus 3 and then 1 minus 1 plus negative 1 and then 1 minus 1 plus negative 2. 1 minus 1 plus negative 2. Okay, so the answer is okay, so 2 minus 1 plus 2. So 2 minus 1, 1, 1 plus 2, 3. Okay, so 4 minus 1 plus 3, 6. 1 minus 1 plus negative 1, so negative 1. 1 minus 1 plus negative 2, so negative 2. Okay, and last one is 2 by 1 matrix plus 2 by 1 matrix and minus by 2 by 1 matrix. So you have 2 plus 3 minus negative 1. 2 plus 3 minus negative 1. So negative 5 plus 2 minus negative 5. Okay, so the answer is 2 plus 3, 5, 5 minus minus 1, 6. Then negative 5 plus 2 minus minus 5, 2. Okay, so this one is addition and subtraction of 4 matrices. Next, scalar multiplication. If a matrix A times by a scalar K, each element in the matrix is multiplied by K. So for example, Okay, so this one. Okay, so K times by matrix A11, A12, A21, A22. So the answer is K times A11, K times A12, K times A21, and K times A22. Okay. Okay, so here example. Okay, so 2 times by matrix 1, matrix 3 by 3. So the element is 1, 2, 3, 5, 4, 1, 7, 3, 9. Okay, so how to do it? Okay, so 2 times 1. Okay, so 2 times 1, then 2 times 2, and 2 times 3. Next, 2 times 5, two times 4, 2 times 1. Next, 2 times 7, then 2 times 3, and 2 times 9. Okay, so the answer is 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 5, 10, and 2 times 4, 8, 2 times 1, 2, and 2 times 7, 14, 2 times 3, 6, and 2 times 9, 18. Okay. So last, we have 4 times matrix 1 by 2. So 4 times 3, 4 times 8. So we have here 4 times 3, 4 times 8. Okay, so the answer is 4 times 3, 12, 4 times 8, 32. Okay, so I think that's all